Hello and welcome everyone to my new and first video on this channel. Today I'm going to be talking about the Suvat equations and we'll show you how to use them on actual questions. So let's get right into it. First of all, I want to explain to you what all those letters mean. Suvat. S is the displacement, U the initial velocity, V the final velocity, A the acceleration, and T the time. So all those things you wanna look at when you have the actual question, like in a test or exam or whatever. Let's now take a look at the equations themselves. As you can see, there is no displacement in the first one, and therefore it's going to be used for questions where displacement does not matter, meaning it's not given to you and you're not looking for it. The second one doesn't have time in it. Because of that, it's also called timeless. And it's going to be used for questions where you don't need time or time doesn't matter. The third one doesn't have the final velocity, meaning you're not going to use it for problems where you don't have the final velocity, right? So now let's see how we can use all of this. In order to do so, I'm going to be using one of my past papers. I'm not going to read all of this to you because of time purposes, but again, if you wanna read it yourself, just pause the video and keep watching. Calculate the maximum height reached by the stone as measured from the point where it is thrown. What we want to do now is see what we got from our Suvat variables. Do we have the displacement? Kind of. We do have the displacement from the point where the stone is released, but we do not have the displacement of the stone going up. So we kind of have part of the displacement. Do we have the initial velocity? Yes, we do, 15 meters per second. Do we have the final velocity? No, we don't. We only have the final velocity of the first part of the throw because as the stone turns around from going up to going down, the final velocity is going to be 0 meters per second. Do we have the acceleration? Yes, we do, because this is done on Earth, so it's probably going to be 9.8, 9.81, something around that. Do we have the time? No, we don't. I wrote this down real quick, and what we want to do now is we're going to have to decide which of those equations we're going to be using to find the answer. So if you want to, you can pause the video right now and see if you can do it yourself. If not, just keep watching. So as we can see here, the question does not include what? It doesn't include time, right? So we're going to use the timeless equation, which is this one, v squared equals u squared plus 2as. So, all right. So now this is basically solved for v squared, but we want it to be solved for s. So we're just going to do some easy algebra, and we're going to find that v squared minus u squared, because we simply subtract this to the other side. So we have v squared minus u squared over 2a equals s. And what you do now is you just put in the values that we found out before. So v squared, the final velocity at the highest point of the stone, is going to be 0. So 0 squared equals 0 minus u squared, and u was 15, so minus 225, which is 15 squared. And then the whole thing over 2 times minus 9.8. Okay, and this, well, we can just simplify this to negative 225 over 19.6, negative 19.6. And then don't forget units, I'm just lazy right now. So if we calculate this right now, we get approximately 11.5 meters, and this is the solution.